All right, now we're going to be doing the fun stuff. We're actually going to be thinking about what is going on, and we are evaluating, and it says write your answer in simplest form. So evaluate. So what is this talking about? How do we pronounce it? How do we say it? Log base 5 of 25. And this would be the answer, and the exponent is always, the answer, because that's what a logarithm is. So it's asking, or it's telling you that your base is 5. We don't know what the exponent is, but we are supposed to get 25. So 5 to the what gives you 25? 5 to the 2 gives you 25. 4 to the what equals 64. 4 to the third equals 64. 8 to the what equals 8. Kind of underline those in the same color so you can figure out which 8 is which 8. And so 8 to the what gives you 8. 8 to the 1 gives you 8. Now what's the base on this? It's a logarithm, right? So if it's a logarithm and you're not given a base, what is your base? Your base is 10, and we're supposed to figure out what exponent it would take if we have a base of 10 to be able to get 1,000. Super easy whenever it's base 10, because all you have to do is count your zeros. So if you had 3 10s multiplied together, you're going to get 1,000. And if that wasn't easy enough, we are going to use our calculator. We're going to grab our handy dandy calculator. There is a log button, and the log button is right underneath your second button. And on these calculators, all you're going to do is press log first. You're going to turn it on first, and then press log, and then do 380 and equals, and we're going to get 2.57978 to the nearest thousands. Again, the number 1,000 has 3 zeros. If whatever that word is and however many zeros is in that word, then that's how many decimal places we're going to have in our answer. So 1, 2, 3. So we're going to look at the fourth number to be able to see if the third number changes. And in this case, it does. And in this case, it would change the 9 to a 10, or 79 to an 80. So 2.580 is going to be your answer on that. What that is saying, let me change colors to kind of clear things up. What was your base here? It would be 10 to the 2.580. If you put that in the calculator, and let me do that real quickly. 10 to the 2.58, and we get 380.19. Now, so this was approximately this right here, because we rounded this number. We're not ever going to get that unless we, do something extremely cool. But this is just an approximation, and so that's why we are rounding. This is your answer. I was just checking when I got that. All right, so 10 to the wait, never mind. I was doing something different. Grab a calculator. Log 4,500 equals 3.65321. Does the fourth number change the third number? No, so 3.653. Now, if you were using your iPhone, if you're doing these at home and you're on your phone, what you're going to do, you're going to go to your calculator and then unlock it so it will flip. And on iPhone calculators, they are backwards calculators. So For this one, you would put in your number first, so 4,500. Don't press anything until you do log. And the log button is right next to your 4 button. So then you press log. Don't press equals or anything like that, and then you would get what you're supposed to get. Okay, now we're back to evaluating. Super, super, super fun. So 125 to the what equals 5. Now, this is whenever you start challenging yourself to figure out what is going on. I'm going from a big base of 125 to a smaller base of just 5. So something has to be going on with that exponent. And lots of people say, well, it'll be negative because you're going smaller. In this case, or in these cases, it's not going to be that. Let's just kind of take it one step at a time. And so let's pretend that it was backwards. If I had the x with the 5 and then 125, well, 5 to the 1 is 5. 5 to the 2 is 5 times 5, which is 25. And 5 times 5 times 5 is 25 times 5, which is 125. So it takes 3 5s to get 125. Okay, so we're going to go back here. So if I have 125 and I wanted to break it down, what you would do, you would take that number and put it over 1. Put it under 1. And what that does, it finds the root. Because remember, if you have 1 on top, then your bottom is your root. And so the cube root of 125 is 5 because 5 times 5 times 5 is 125. So if it gets bigger, from a bigger base to a smaller base, chances are it's going to be a fraction like that. Okay, evaluate. Write your answer in simplest form. So our base that they didn't give us is 10, and we don't know the exponent, and I need 1 over 10. Okay, well, 10 to the 1 is 10, right? So these numbers stay the same, which is a good thing. But that 10 turned into a fraction. This is when the negative comes in. If you have a base that is a whole number and you have an answer that turns out to be a fraction, something flipped it. And what flips it is your exponent being negative. So this would be a negative 1. It's negative because it flips, and it's 1 because 10 to the 1 is 10. So 1 over 10 to the what gives us 1 over 100. So in this case, our base is a fraction, and our answer is a fraction. So nothing was flipped. So our answer, our exponent, is not going to be negative because nothing went wonky on it. Basically, it's like 10 to the what gives you 100, and your answer is 2. And then this one, 10 to the what gives us 1 over 1,000. Well, 10 to the third will give us 1,000. So I know that 3 has to be part of the answer, but to be able to be from a whole base to a fraction answer, it has to be flipped, and what flips it? A negative exponent. So if our exponent was 3 to be able to get 1,000, then it's going to be negative 3 to be able to be flipped. And this is 1 over 6 to the what gives us 36, and 6 squared equals 36. We should all know that. But if this is a base, the fraction is a base, and then it flipped, to be able to get an answer that's not a fraction, anytime it flips, your exponent's going to be negative. So it's 2 to be able to get the 36. It's negative 2 to be able to flip it. And that's it.